Yeah. Good. So let's see. So our test three will include chapter 5, 6, 7, and 8. Chapter 5 is about continuous distribution. Chapter 6, we also work on continuous distribution, but we specialize to the normal distribution. In chapter 7, about central limit theorem, the most important theorem in history of statistics. And chapter 8, we start to look at application of probability in the statistics world, and by look at the interval, confidence interval estimation and point estimation. So you can see like our practice testing, we have problems like related to all chapters here, 5, 6, 7, and 8 here. Okay, so let's us walk through each problem. So for the first problem here, you have phi 1 here. You have probability density function of continuous random variable where the uh, PDF, right? The density function is the blue curve here, blue curve. And the error under the curve will give us the whole probability, which is 1. So the whole error here will be 1, right? Under the curve, be 1. To make sure it's the definition of probability, it satisfies the definition of probability. The total sum uh, must be 1. It cannot exceed 1. So the first question asks you to find the probability x greater than 11. So basically you need to find the error where x greater than 11, right? So which means at that time maybe let's triangle here, this area. So it's if you can find the answer for this, you can find the error for this triangle, you finish the task, right? And you remember the triangle, this is a square triangle. So the formula is that like we have of like this side times this side, right? So half of us, so if I call this A and this is B, so it would be half of A times P, right? So this is probably X greater than 11 here. And you can see when you look at the graph here, A will be basically like A, right? This side will be actually just 1 over 18, right? 1 over 18. And B will be from 11 to 15 will be 4, right? So we will have this quantity. And then because if you, and then you just plug in and find it, right? I think like we do have the answer here, uh, which is 19, right? 19, 19. And the error x less than 11, basically we can look at A and B. They complement each other, right? And remember, for the continuous distribution, the equal sign does not matter, right? So x less than 11, probability will be equal to 1 subtract x greater than equal to 11. But because the equal sign does not matter, right? So you just can throw it away, right? Yes, 1 subtract 1 9, right? So you get A 9. A 9. And how about from 9 to 11? 9 to 11, right? 9 to 11, which is this area. You have the trapezoid here, right? So if you remember the formula to find the area of the trapezoid would be half of this side, right? Plus this side and times this side, right? So if I call here like E, maybe C, I call here D, and I call here E. So it'd be half of C plus D times E, right? And basically like you just plug it, right? The C here, you can look at the graph, it would be just 12, right? C will be here, the hole here, because we have a rectangle, right? So which means it should be 12, 112. And D, which is 118, and time E. E is from here, from 9 to 11, which is 2, right? And if you're not so sure about calculating manually, you just plug in a calculator. I think will be more efficient. Because last time in the test, I saw a lot of you perform manual calculation and you make it wrong. So I would suggest like if something you're not so sure, then just use a calculator and plug in. Okay. So here you can see that. Oh, here they use another strategy by using lesson 11 subtract lesson 9. That worked too, right? So lesson 11 you borrow from here and you'll find lesson 9, which is, yeah, I think maybe also a smart way. The try rectangular here, right? Lesson 9. So which is mm, will be this side, right? Time this side, right? So just 112 in time 9, right? 9. That works too, right? But yeah, you plug in, I believe you should get the same result, right? Which is 5 was 36. Okay, you can check it, verify it. You can make it decimal too. So in 6, right? First, given the plot to normal, which the following statement true, correct, or answer. So in order to choose the all correct answer, you need to know how to look at the normal distribution, right? First, the normal distribution is represented by two quantity, one is the mean and one is standard deviation. The mean is show the central tendency, right, of distribution. So, when you look at the mean, you should look at the peak, where the peak is, right? So for, let's see, the red curve for the normal red, so the mean will be corresponding to this place. I call mu A here, right? And for B, we say the mean is corresponding to the peak here, so it's something like mu P here, okay? So you can see that, and for the standard deviation, the pointier distribution will have a smaller standard deviation. So from here you can see like the standard deviation of the B, it must be bigger than A, because like A is more pointy, so which means its standard deviation is smaller, okay, and B standard deviation will be bigger. So which means B, they more spread out. The data from B more spread out compared to the A data from A. So from here you can see that the mean of the B will be bigger than A, but and also right, in this case the standard deviation and the variance of B also bigger than A. So you just choose all the correct answer here. So A has larger mean, which is wrong. B has a larger mean, right? Mean A is not correct. A has larger standard deviation, no. B has larger, right? So right, this is choice here, right? Okay, so for 3, John averaged 58 words per minute on a typing test with a standard deviation 11 words per minute. Suppose John was per minute typing set normally distributed, okay, X number words typing per minute on a typing test, right? And here X will follow a normal with 58 and 11, okay. So suppose John types 72 words per minute in a typing test on Sunday. Find Z score, right? So this is a z-score problem. So the z-score is nothing else than just the, if you recall the number, the formula, right? X subtract X bar and divide by sigma, right? Sigma, right? X subtract mu divided by sigma. So in this case, L mu is 58, L sigma is 11, right? So here just like you plug it in, yeah, X is 72. So it would be 72 subtract 58 divided by 11. And here the mean is 58, right? So you can plug in and see how much we get, right? If you plug in and you do the calculation, it's the 1273, right? 1273. 1273. And the mean here is 58, right? 58. So this is going to tell you that x equal to 72 is blank, right? Standard deviation to the right, left, two of the mean, right? So here you two things you need to do. One, you need to circle whether it's right or left, and another thing you need to circle is that like how many standard deviation, right? So this going to tell you a number of standard deviation far from the mean, right? So in this case we already calculate it's 1273, and because this is a positive number, right? So which means it's higher than the mean, right? Basically it's just at the right of the mean, right? It's at the right of the mean. So you can think like, okay, so it's the x is the normal, right? 58, number of typing word is a normal of 58, and standard deviation is 11, right? And on Sunday, he typed about 72 words. So which means he about here, right? So this position is a 1.273 standard deviation above the mean, right? And the mean here is 58, 1.273 standard deviation to the right of the mean, above or to the right. It's the same thing, okay? The same thing. So for number 4, they're asking John scores playing pinball are normally distributed with a standard deviation of 20 points. If John scores 562 points and this score is 3, calculate the mean. So this kind of backward problem, right? So now you have the z-score value, you have the value, you have a standard deviation, and you need to find the mean, right? And remember, just recall z-score formula again. Z-score equal to x subtract to the mean, right? And divide by standard deviation. And now you plug in everything, right? So we have 3 here, this score, right? E3. X is 562. Be careful, okay? X subtract mu, not mu subtract x, okay? And mu you don't know and you want to find it, right? And standard deviation 20. So now you just find the solution for this problem, right? Find the mu such that this satisfy, right? And this just basically, I think, my fourth grade problem. And what you need to do is that you just time both sides with 20, right? It will be equivalent with 60 equal to 562 subtract mu, right? And which is equal to, now one way you can do add both sides with a negative 560, right? So this will be 60 negative 560 equal to mu. Well, that's right. And this guy will be negative 502 equal to negative mu. And you time both sides with a negative 1, and basically you can guess 502 equal to mu, right? So your mu is 502. Let's check if we have the correct answer here to, yeah, 502, right? So this is solving this problem. Some of you may know how to do this problem faster, right? Just twist like 20 and flip uh, 3 times 20 to the other side, flip mu to the other side, and just one line. You can also get to mu to 502, but here I just rewrite step by step for you to easier to catch up, but more or less it's a kind of forward type problem. So in fine, Porter was told that his test score was standard below the mean, okay, which is negative, right? Negative to the left of the mean, right? If the test score were approximately normal with mu 75 and sigma 6, what Porter score? So now you know this score is -1, right? Because one standard deviation below the mean. The z-score, again, it just tells you how many standard deviation far from a mean. So if below to the left, you have a negative z-score. If above to the right of the mean, and you have positive z-score. So here, like, I won't write the z-score formula again here because we have it here already. So I just plug in, okay. So because his test score one standard deviation below the mean, so we mean the z-score is -1, okay. Because below the mean, okay? The negative come from below the mean, to the left of the mean, okay? And equal to the x, which is test score we need to find. Subtract the mu is 75 and by 6, right? And then you need to find the x, right? X. So you can see that time both sides with 6, right? Subtract 75. I just go with a slow track, okay? And you add to both sides with 75, right? So basically, his is test score 69, right? 69. Let's check if we get it correct here. Perfect. Here, a normal distribution is observed from a number of points per game for a certain basketball player. If the mean is 16 points and standard deviation is 2 points, use empirical rule, okay? Determine the following. So first of all, what empirical rule tell us? Empirical rule tell us like 68% of observation fall from one standard deviation from mean, right? 95 to 99.73 standard deviation from the mean, right? So here, like you have a normal distribution with mean is 16, right? And standard deviation is 2, right? 2, right? So here, like, what probability a randomly selected game player score between 12 and 20? So they want to ask you between 12 and 20, okay? 20, right? So you find error here. So actually, at this level, you just simply can do just a normal CDF, right? Normal CDF with the mean of, so basically how, what you have in X follow a normal 16, 2, right? And you want to find the X 12, then 20, right? So if you do normal CDF, okay, you can do normal CDF. The lower bound will be 12, about 20, right? And then the mean will be 16, standard deviation 2. So it will return you the number, is the exact number, okay, from the calculator. But because, you can also use the empirical rule, okay? So if you want to follow empirical rule tracking, you just remember, okay, do standard deviation from the mean in 95%. It's a rough estimate, okay? It will not as accurate as using normal CDF function, but a rough estimate. 3 standard deviation from a mean, we have 99.7%, okay? So at the time, you see that 12 is 2 standard deviation below 16, right? Because 16 subtract 2 times 2 will be 12. And 16 plus 2 times 2 will be 20. So basically, like this is the error 2 standard deviation far from the mean, right? 2 standard deviation below, 2 standard above. So if you look at the empirical rule, basically this should be around like 95%, right? 95%, right? 95% to standard deviation from the mean, right? Area. But again, yeah, from my perspective, there are no reason to use, the excuse me, the empirical rule here in because at this time you have a calculator already, and you already know how to use normal CDF. But anyway, yeah, empirical rule also applicable here. And I give you a rough estimate if you don't have a calculator in hand. Okay. What probability a randomly selected game player score more than 22 points, right? So at the time, you see the power of the calculator, right? So you want to find their probability score better than 22 points, right? So again, you can use empirical rule here for sure, but I would suggest, because this is a test, right? And you have the calculator in hand, right? There's no reason to waste your time to do some manual calculation. Okay, so just normal CDF, 22, very big number, right? And then 16.2 here, right? And you just plug in, right? Plug in the normal CDF function, and you should get your number, right? But say, if you still want to stick with empirical rule, it's still doable, right? And basically, like if you look at empirical rule, how you look at it, yeah. So you have 16 here, you have 2 here, is standard deviation. So 22 is 3 standard deviation from the mean, right? So it is 22 here. And this is 3 standard deviation below will be 16 subtract to 3 times 2, you get 8, right? And you know that 99.7% of your data will belong to this area, right? 99.7%. So which means, and because of the symmetric nature of the normal distribution, so which means each of them will be half here, half of the remaining, right? So the remaining will be 1 subtract to the 99.7%. So each part will be half of that. So this will be 1 subtract, okay, subtract 1997 by 2, right? So if you don't want to use a normal CDF function, you can only use this strategy. That works too, right? So what probability runner selected game player score less than 14 points? So 14 is 1 standard deviation below the mean, right? So again, the first track, which I would recommend you to use in the test to optimize your score by going with this track. Not more CDF. A very small number, right? 14. And then 16 too, right? And you just plug in, you get your number. But say if you don't have a calculator, you just want to loyalty, show your loyalty to the empirical rule, and then you can also go with this fashion, right? Okay. So you have 16 here, and 14 is 1 standard deviation below the mean, which means the next guy will be 18, right? So here, if you remember, the empirical rule tells us 68%, right? The data, 68 before 1 standard, the standard deviation for the mean. So which means the remaining area will be 1 subtract 68%, and because symmetric, so each of them will be half of that, right? So this guy will be half that, and you want to find this guy, right? So just 1 subtract 0.68 by 2, okay? You plug in. Let us just go use the normal CDF function maybe with one problem, right? And then to give you review how we can access the normal CDF from your TI calculator. So for the normal CDF, TI 84, this, okay. Oh, yeah, okay. Okay, so you can do Start second distribution here, no more CF, right? So maybe you look at scale small. Okay, good. So for the maybe I will do the last problem. Okay, 14, right? Part C, no more CF, negative 999, 14, 16, 2, right? Negative 999. They already give us a very small number already, but I just make it here for consistent. Okay, and remember again, you need to use the sign for a negative sign. Okay, not this one. This one a minus, and this one a negative. Okay, up will be 14, 16, 2. Okay, see how much here. Oh, missed that here. 1159. 1159. Yeah, 1159. Let's say if you use empirical rule, you see that it about subtract 3, 6, 8 divided by 2, you get how much here? 1, 6, right? 1, 6. Yeah, it's slightly different, but it's closely, right? Very close. So either way, you should get the full credit, okay? For this problem if you do follow either of the track. And for sure, this track, the normal CF track will be the more accurate. And the empirical rule just approximation in case you don't have the access to the calculator. Then see, next we move on with more focus on normal distribution. And I think, believe from now on, with this kind of question, right? And then empirical rule, very tricky because empirical rule just only help you with a certain value, right? One standardization below or above, 2, 3. But what if we have another value? Say, for example, like in this problem, right? We don't want x less than 14, but we want the probably x less than 14.5, right? And for sure, you cannot find any standardization. That's, it will be a number of decimal. It's not like 1, 2, 3. It can be, I believe it may be point something, 0.8 or something, right? 0.9. So other time you need a normal CDF function because it can give you access to the whatever number, and you just plug in the boundary, right? But in empirical rule, at that time it won't work. But it does have a benefit in case you don't have access to the calculator, and it gives you a fast answer for a lot of questions too. So here, like the final exam score in science class were normally distributed between 60 and standard 7, right? Final probability, okay. Random selected students score more than 70 on the exam. Below the mean, less than 50. B, which is between 80 and 89. So all of these like kind of normal CDF problem, right? You have the value, you find the error under the curve. So here, the exam score X will follow. If X is the final exam score, right? And X will follow normal, which means 60, and standard 7, right? And the first question, find the property X greater than 70, right? So it's just normal CDF, right? Normal CDF. 70, a big number, mean and standard deviation, right? Below the mean. So this way, the mean is 60, right? So basically, the x less than 60. So you can do the normal CDF again, or you can just look at the property of the normal distribution, right? Because symmetric around the mean, total error under the curve is 1. So which means below the mean and above the mean will be equal. We have, right? Will be half. You remember that it's symmetric around the mean, right? 60 here, symmetric here, and the total error under the curve is 1. So which means this guy half. But you can also, for sure, just naively apply this guy as well, right? So either way, But I believe if you know the property, you can say it sometime here, right? The normal. You don't need to look at the normal CDF function and insert in your calculator. Find probability that a randomly selected student score less than 50 on the exam. So less than 50, right? So again, it's a normal CDF, right? CDF 999, 50, 67, right? Find probability randomly selected score between 780 and 99, right? Again, score B, right? Again, the equal sign here does not matter, right? Because we have a continuous distribution. Right? So if you plug in all this, and we do have, and we have an answer, and I believe we also have the answer here, right? Yeah, just like this, or answer here. Here again, let's see. 2,000 students took an exam. The score exam approximately no more mean 81, and standard is 5. Okay, so X you follow normal 81, standard is 5, right? So the middle of 50% score between the two value. Oh, so basically, like in this case, you're asking something like this, right? You ask something like this. You find two value A and B, where here in the middle we have 50% of the score, right? So here is the 81 and standard 75. You want to find A and B here. So for this type of problem, you have the error under the curve. You want to find the value, right? It's kind of backward with the problem 7. You have the value, you find the error under the curve, and now you have the error, you find the value. So for those of you who have a new version calculator, and then it will be easy, right, for you, if you want to solve A. So you just do a distribution here, and inward norm, right? You tell your calculator, okay, I have the error 0.5 here. The mean of mine is, let's see, 81 and standard 75, right? 81, 5. And have a center error. Center error. So you see, it will give you like 77.628 if you round up, right? 77.628 to 84.372, right? So it gives you the area here. But say if you have an older version, and this you don't have the option of center right here, right? So what you need to do with that, like you need to do some more labor by finding what the error before A, what the error after B, right? So in the lecture notes, we have the formula for that, right? So because it's symmetric, right? The error, shade error is 50%, which means two sides here, right? Each of them will be 25%, right? So this guy will be 25%, and this guy will be 25%. So from that, you know, Px less than A equal to 25, right? Upon 25. And you just plug it inward norm, right? Upon 25. 125 and 81 and 5, right? And for B, because probability X greater than B equal to 125, right? And so which means probability X less than B is 0.75. So B is the inward norm of 0.75, right? So you can see, you can get this value too if you have an older version. And again, the equal sign does not matter for continuous distribution, okay? And we do have the answer here. Let's check. I think, yeah. So here the solution provided for the older version of the calculator. So what the value represents 10 percentile. So here the score here, right, is this normal, and you want a 10 percentile value. So basically, like you want to find this, right, 10 percentile, a bit over here, 10 percentile, 10%, right? So we want to find this value. So basically, like the 10 percentile value, RP10 here, will equal to invert norm upon 1, right? And the mean and standard deviation. And you plug in, you get it. How about what the value separate the top 5% of the rest of student? So the top 5%, which means the 95 percentile value, right? This is the same thing, the same way of talking about the same thing, right? Talking about the same thing, right? The 95 percentile and the top 5%. Just a different way to talking about the same thing, right? So this guy would be 5%, right? Which means this at the opposite side would be 95%. So at the time, this guy will be just basically like the P95, right? Inward norm 195, 81.5. Okay. So you plug in your calculator and you should be able to get the results that provided here. Okay. And again, for those of you who have the newer version, and be mindful that when you after you do A, you choose center error, or when you do B and C, you need to choose that left error, right? Left error. Don't leave the error at the center as you did in A, because it will make you wrong, uh, give you a wrong number, right? So here, like in the 7, we look at the central limit theorem. So central limit theorem, it tells that basically like if you have your data follow some population, which we don't know, we mean mu and standard deviation sigma, right? If you have your sample and the sample size either large enough or your data, which is roughly speaking n greater than 30, right? Or your data normally distributed, right? And at that time, your sample mean will follow a normal, which mean is the same as the mu, but the standard deviation sigma will shrink from sigma to sigma by square root of n. Here n is sample size, okay? So the beauty of that is even, the original data may not come from a normal, but if you have large enough data set, right? And at that time, the sample mean of your data will behave very nicely by following a normal distribution with the same mean as the original data, but the standard deviation will be get shrink. Okay, so here, like the average time it takes a certain brand of ibuprofen start working in 25 minutes with standard deviation 13 distributed normally. Okay, so the original data here, it has a mean 25 and standard deviation is 13. A pharmacist randomly choose 20 pills from this brand because she researched in different brands in order to find the quickest acting ibuprofen to recommend to her customer. Identify the following to help her make recommendation around the nearest unless if necessary. So it just keep 3. Okay, you won't lose this credit for all kind of problem. You keep 3. Okay. So here in this case, what I mean here is 13, right? The original data here. The sigma here is, I'm sorry, 25, right? 25. 13 here, right? And the n here is 20 pills. And so because with the central limit theorem, it tells us the mean of the sample of 20 pills here, it's just the same, right? It's just 25. No, don't change. But the sigma of x bar, the sample mean will change, will shrink. It's no longer 13, but it will be 13 by square root of 20, right? 20. So let's look at the solution. Yeah, it should be. Yeah, so you can also calculate further, which is 2.91, right? So here assume that the game playthrough times for a newly released puzzle game has mean 49.8 minutes, installation of 4.2 minutes. So round the answer to the 4 decimal places. So for this problem, okay, let's look at what they're asking here. If one game is randomly selected and assume that the playthrough times is normally distributed, find the property playthrough time between 50 to 51 minutes. Okay, so for this problem, uh, the new release puzzle game has a mean 49 and 0.8 and solution is 4.2, right? So we have the time, maybe say time play in time, whatever, right? So if we didn't know x in the play in time, so x follows something, right? We don't know it normal or not, okay? Because for part A, they only assume normal for part A, but for part B, they didn't say anything. So it has a mean is mu equal to 49.8 and standard deviation is 4.2, okay? Which is standard deviation. So here, if one game is randomly selected, right? And here they assume normality here because one only one game, right? So basically it's just original X here. So yeah, X here for one game, right? I maybe don't know by X1 here. Okay, for the one game is will be equal to X. And follow normal, they assume normal here, okay? G49 on A and submit 4.2, right? And now you want to find the property X from 50 to 51, right? So now this problem becomes to you have the values you want to find the error under the curve. So which means it's just a normal CDF function. Normal CDF 50, 51, and the mean and the standard which is 4.2, right? 49.8, 4.2. And here in B, if 39 games randomly selected, find the probability that the sample mean between 50 to 51. So this problem will be different. So here we don't have the normality assumption anymore, but we should remember that for the central limit theorem to be applicable, right? If we don't have normality from the originally the unit large enough sample size, in this case 39 is already bigger than 30, right? Bigger than 30, which is roughly speaking, we say we have kind of decent number of sample size. So which means at the time your X bar, which is X bar from 39, okay? The X bar here, it will follow a normal by central limit theorem, right? Because 39 bigger than 31. Okay, so we apply the central limit theorem, right? CLT, central limit theorem, applicable, right? Applicable. So X bar will follow a normal with the same mean, but standard deviation shrink from 4.2 to square root n. In this case, yeah, n is 39, right? And now you want to find the property of X bar between 50 and 51, right? So which is normal CDF, excuse me, 50 to 51, and then 49.8 and 4.2 by square root of 39, right? And you plug in, and you should get it. So in part A, it was assumed that playthrough time are normally distributed, and in part B, not necessary. So the reason again is easy, right? So for part A, in order to make a calculation work, you need a normality assumption, right? And maybe some other assumption which the distribution must be explicitly specified. But in part B, at the time you have a sample mean, and because you don't have a normality assumption, but the case here you have large enough sample size, So the central limit theorem applicable, so which means you can process the problem forward, right, to achieve the task. So let's look at the solution here. The same thing, right? Normal CDF here, right? Okay, so this is already here. Okay, so let's see 11. 8,900 incoming freshmen to university take an entrance exam with a top 10% of being offered admission to university's honors program. The average test score is 78% with a standard deviation of 11%. Find what's the score the student must score to be invited to join the honor program with only 65 score look at to determine the honors admissions requirement. This problem is not so clear stated. I would tell you that thing, okay? It's not so well stated. But basically, I think the main idea uh, uh, they want to ask you is that basically like here, you have a test score is follow or normal or something, right? We don't know which is the mini 878 and the standard is 11. Okay. And now you just look at 65 average score, right? And basically, like at the time, in the central limit theorem applicable, right? So the average test score will follow a normal of 78 and 11 by square root 65. And they want to find the 10% of the average score, okay? 10% of the average, the top 10%. So basically, it's just a 10%, 90% type problem, okay? So if we see this problem in the test, I will explain it for you what your task is. But this problem not stated so well. Okay. So basically, you want to find what is this value, right? Here is mean is 78, and the standard deviation is 11.65. Okay. So basically, like what you need to do is that you need to find the P90, right? Percent. And P90, 90% type value. It should, I think I wrote P90 already, so switch here inward norm, make it consistent here. 19 and 78 and 11 by 65. Okay. So let's look at the solution here. I think this is what I guess correct. But basically, like this problem again is not very well stated. Okay. If we see it in the test, just let me know. Okay. And again, for any question, if you feel unclear what I ask, they ask you to do, and then just talk to me, okay? There's no reason to do something where you don't know what does it mean, right? So in chapter 8, we talk about confidence interval, right? So confidence interval, so here like there is two quantity we interest in for this class, the proportion and the mean, right? And we have a point estimate and confidence interval estimate. So here in 12, a cashier at a convenience store is reviewing the sale over the past 3 months. She found the mean amount of daily based sales to be 280 and margin error is $16. Construct confidence interval. Okay, so this is a kind of very easy problem, right? The error is the E, and the confidence interval will be x subtract E to x plus E, right? When we talk about confidence interval in the mean, so you just plug in, right? X subtract 16, x plus 16, right? So which is 264 to 96 to 296, right? For 13, a random sample college and professor will ask they will develop online course it offer Resulting confidence interval for a professional professor who will develop online course is from 4 to 5 6. What a margin error. So here you have upper, you have a lower bound, right? Here the upper, here was lower, right? Upper bound, maybe up the upper, lower. Okay, I put lower here. So if you remember the formula, we have a relationship between the point estimate and the confidence interval, right? So the upper is basically like here in this case, we talk about proportion, right? It's just P plus E, right? P plus E, and the lower just like P subtract E, right? And now you can see that if you upper, you subtract lower, you get 2E, right? So if the upper here, you subtract lower, okay, and you get 2E. Other E will be 2E, okay? Or E will be upper, subtract lower, okay? Divided by 2. And E here is just margin error, right? Margin error. So it would be 156 subtract 144 divided by 2, okay? 6, right? 56, no. 56. And we do have a solution here as well, right? And the same thing here, okay? So for random, you see there's a statistics student, you confidence interval generated, okay? For submit. So here you have the interval and you want to find the point estimate, right? And again, you also have the same relationship, even for the mean, right? Here you want to find the point estimate. You don't want to find the error. So this guy is basically just X bar subtract E, right? Or the lower, right? And this guy is upper, right? X bar plus E. And remember, if you do the upper, you plus the lower, the E and the E cancel out. What you get will be 2X bar, right? At the time, your X bar will be upper plus lower divided by 2, right? And you plug in now, upper 98 plus lower is 76 divided by 2. So it gives you the answer, which is, I think this is wrong. Okay, here. Okay. This is what we need, right? We don't want the error here. But anyway, here is, I think there's some redundant part. We don't need to show this guy, right? So last one for this part, A1. A librarian is checking the length of book found in a teen section in library in a random sample of 250 books. She finds that 25 books have length of 150 page or less. What value should be used to calculate confidence 98% confidence interval? Okay, so here like we talk about the length, right? And in random 35 and 25 have book length. Okay, so the confidence interval here is for the, so in a random sample 250, she find 25 book. Okay, so probably she look at the mean. Okay, look at the mean. Yeah, she look at the mean here. Basically like it's just find the mean, right? So what the value should be used to calculate confidence interval for mean? Okay, this is not very well stated again, right? Okay, but it should be like a mean is a type problem, okay? Because in our scope, we only learn either the mean and proportion, and here we talk about the length of the book, right? How many pages the book have, right? So what value should be used to calculate confidence interval? So you remember confidence interval for the mean, and in this case, they provide us, let's see, uh, basically like only the z, right? So for confidence intervals for the mean, we should have two cases. Either use z distribution or use t distribution, but here they just provide the z. So I mean, at that time, probably CC having large enough sample size, so she can approximate by normal as well. But But again, okay. So anyway, um, so here, like basically, like the confidence interval for mean, if you recall, uh, it will be mu x bar, right? Subtract if you use z distribution approach, right? Z 1 alpha by 2 with the notation from my lecture note, okay? And s divided by square root n, right? Sigma, I mean, if you use z, it has to be sigma, right? Sigma by square root n. A more correct version, it should be the t, okay? But because here they only provide the z, so but in general, if you have 250 books, the z is also a good approximation for that t too. So let's just stick with that. We should do whatever we have, okay? Sigma by 2 square root n, okay? So what the value of the interest here is, what is this guy, right? So the guy here, so in this case, we want 98% confidence level. So which means your alpha 98%, right? So the percent and percent cancel out. So basically you get like 1 alpha equal to 0.98. Yeah, alpha 0.02, right? So which means your z 1 alpha by 2 equal to z 0.99, okay? 1 subtract 0.02 by 2 z 0.99, okay? And this is just the inward norm, 0.9901, okay, 01. And because in my lecture note, I already give you the remark that the way we know the z critical value is slightly different with what happened in the textbook, right? And maybe in the homework. So we use Z99 to denote the thing they call Z0.01 here, okay? And we use Z0.01, and basically they will denote at a negative 0.01, okay? So again, if you use textbook notation, okay, displays the 1% here, okay? They will denote by Z0.01 and display 1% here. They will denote by negative Z0.01. Okay, so this is what happened with the textbook or the homework. Okay, but in my lecture note, I try to make it straightforward, and it will help in chapter 9 by using like this. So this is the 1% value, 0.01. I didn't know that. Okay, 1%. And this is the corresponding to 99% high value. 99%. Right. And this guy 1% here. And then 0.99. Okay. So notation is slightly different. Okay. So if you're confused, you can also ask me. And if I see this, just, if you see such a thing in the test, just let me know. Okay. Let me know. But anyway, I think, yeah, and she choose the answer here is just the same, right? Inward norm 0.99. Okay. So no matter what kind of notation is, right? When you plug into a calculator, you need to tell the error, which is 0.99, right? And this is why I prefer to stick with Z0.99 as Z1 alpha by 2 strategy here. So in 16, the age of a resident in zip code are normally distributed with unknown person mean and standard deviation. A random sample of 22 residents is taken result sample mean 56 and sample standard deviation 7 years. By 95% confidence interval estimate for population mean using a student distribution, okay, around to 2 decimal place. So again, just keep 3, okay. You shouldn't get a loose credit, okay. So make it consistent. We are 95%. Okay, so there are 2 parts here. So first find the confidence interval, and then just fill in the blank, right? So here, like in this case, because they don't say anything about the sigma, the population, right? So it's you need to do with the t interval, right? T interval, student t distribution. And here you have the process data, which is 56 and solution is 7, right? Um, so now let's plug in your calculator, right? Calculator. So which means in this case, you do start, test, and t interval. And because you don't have the raw data, you go to start here, enter, okay. And the X bar, what they gave us is 56, right? 56. 56. The SX is 7. The N is 22. And the level we want is 95, right? Okay, so we got everything here. So from 52.896 to 59.104, right? 52.59. 59.104. Okay, so basically the 95% confidence interval lie between this at 6104. Okay, so let's look at the answer here. Okay, so which means we are 95% confident that, okay. Okay, then again, the time for knee surgeries are normally distributed by unknown population mean estimation, a random sample of knee surgery. So here you have already that, right? In this case, use a calculator to find 95% confidence interval for the population mean. Let's see, we have enough. By the way, I think we should have enough. Okay. So at that time, you can see that um, just insert the raw data, right? The same thing. So here you have no information about the sigma, right? Again, so you just give the t interval again, but just we need to insert all the data here, right? 92, 91. So let's do start, edit. Okay, so 92, 91. What else? 105, 1110, 105, 1110, 125, 107, 125, 107, 1110, 98, 1110, 10, 98, and then 101, 115, 101, 115, and then 108, 109, what's there? 108, 109, and 97, 99. Okay, finally, 99. Okay, it's kind of continuous, right? But what can we do? You can do your manual calculation if you don't like the calculator. 92, 91, 105, 1110, 125, 107, 1110, 110, 98, 110, 98, 101, 115, 101, 115, 108, 109, 97, 99. Okay. So we have the data in L1 already. So now you go to start here and test, and you know to test, right? And T interval again. And at the time, you need the data, okay, data track. So we want L1 here, interval E. The level you want in 95 again, right? That's good. You have it here. This is your interval, okay? 99.454 to 110.12, right? 99.454 to 110 point. Okay. Yes. So let's check if they give us the correct answer here. Yeah. So again, which means like the interpretation will be, we're 95% confident that the true portion mean lie between these two values, right? I say if 100% do collect 100 some more data, right? And 95 of them will have their interval and will capture the truth, right? So here the last batch is about the confidence interval proportion, right? So here like Louis wants to estimate the proportion of people in an airplane who are under 35. He surveyed to 35 airplane passenger and find that uh, 15 are under the age 35, right? Find 95% confidence interval for proportion. So this is just a proportion interval, right? Function. Uh, so in this other time, you just basically like what you need to do is that you need to provide what the sample size, right? And what your X value, which is number of people satisfy the probability, right? And the confidence level for your TI calculator. So here you do start and test. And what you want proportion Z test interval, right? Yeah. So 1% Z interval here. The A option here. Your X in this at the time will be because 15 under the A, right? Hit your X. And here we have like this much in the N, right? And the confidence level you want the one here is confidence level of 95, right? So you just plug in, right? Your X is 15. Your N in the number of people you survey is 235. 235. And you want 95% again. Okay. Right. Enter. So you get like 0.033, 0.095, okay. 0.033, right? 0.095, okay. Let's look at it. Okay. So 0.033, 0.095, right? So 1% interval. Perfect. Again, the same thing, right? The same thing. Robert wants to estimate the proportion of a first-year student resembling a mid-teen. He surveyed 75 students and found 40 of them first-year student, right? So here the N is 75, the X is 40, right? X is 40, you want to find, right? So again, you should do the same thing, right? One proportion, the interval, and then just repeat the procedure as we just did, right? Provide the X, the N, and the confidence level, okay? And you should get the answer for this question too, which means also showed here, right? 422646, okay? So the last question is about the sample size problem, okay? So the sample size problem is that, let's see, suppose a manager shoe store wants to determine the current percentage customers who are males. How many customers should they manager survey in order to 90% confident that the estimates sample proportion within three standard percentage points of the true population proportion of customers who are males. Find sample size. Find this score to this most visual route, okay, up nearest integer. So this is just some additional instruction, but whatever, I think we let's just keep 3 for all cases. You should be fine. So for n, it's a sample size problem, right? So basically, it's the cell, right, of the proportion p hat, 1 minus p hat. So in this case, you see that there are no additional information for proportion p, right? So basically, we just use half, right? Use half, but we talk about that later. The 1 minus alpha by 2. Here I use the notation in my lecture note, okay? So if you use follow a textbook, it will be the alpha by 2 by E. So this is the formula, okay? And because we have no information about the proportion P, so we just use half, just a random yes, right? So which in this case would be half the cell function, okay? So basically after you find the solution for this whole big quantity here, and then you just celled up, right? So because here like your confidence level is 90%, so which means your 1 minus alpha, right? Then 100% equal to 90%, right? So which means your alpha will be equal to 0.1, okay? So this means z y minus 0.1 by 2, okay, square. And the error here is 3 percentage points, which means like 0.3, okay? 0.3 square, okay? Okay, so this is how you find this value. And say after you find this value, right? So this is basically just the 0.95, right? So basically you can maybe do one more step with manual calculation here. Times z square of 0.95. This value is just an inverse normal 0.95, 0.1, and you square it, right? And divide by 0.03, which is 0.0009, right? So if you plug in, right? You plug in and you should guess this value, 7,501 divided by 0.7, okay? And because you sell it, which means you make 752, right? Here's 751.7, and you round up, right? You sell it, so you get a 752. Okay, so we finished the review class here. And please let me know if you have any question. Okay. Next Monday we have a class for the starting with chapter 9, hypothesis testing, and then if you have any other additional question related to the test, we can also discuss. And on Wednesday we will have the test 3. Thank you for your attention.